I think the single biggest thing is that space is now more important than air. To the joint fight, we do not succeed without space and the Space Force succeeding.
Dr. Williams is the Deputy Technology Executive Officer for Space at the Air Force Research Lab, or AFRL. He's been there for nearly 20 years, and in that time, he's watched the space domain transform from what we used to call a relatively benign environment into a full-on contested warfighting domain. His job, as he describes it, is to be the conductor, making sure all 10 directorates inside AFRL are working together to serve the needs of the Space Force. The challenge of transitioning technology from the research lab into programs of record. Why dynamic space operations may be the most important capability we're not moving fast enough on. And this one landed for me. Why cutting the science and technology budget isn't saving money. It's mortgaging the future. I'm Bill Woolf, and this is Space Power. It truly is an honor to be here at the Redwire Stage at the 41st Space Symposium hosted by the Space Foundation. What another great event, and what an honor it is to be here with Dr. Williams to talk about everything going on at AFRL regarding space. So the theme of this interview and discussion is going to be research to warfighter and describing that pipeline. Because not a lot of people, one, understand that there's a Space Force. I was talking to some Guardians today, and they're saying that they walk around here in Colorado Springs, and Colorado Springs folks will take a look and say, Space Force, is that a real thing? And so it's our job really to help get the word out about what the Space Force is doing and all the important work that AFRL is doing. Now, Dr. Williams, I can sit here and read your bio, and that's a lot. It's a long bio, and you've accomplished a lot because you've been at AFRL now for about 20 years. Yeah. I mean, almost helped stand up the space program at AFRL. So instead of me reading your bio, what I'm going to do is I'm going to ask you a question about your bio. So as I said, you've been there since 2003. You've watched this domain go from a relatively benign environment, the way we described space in the past, to a full-on contested warfighting domain. What's the single biggest shift you've seen in how AFRL thinks about its mission?
First and foremost, and I think this would be a contentious statement for the air side of AFRL, but I think the single biggest thing is that space is now more important than air. To the joint fight, we do not succeed without space and the Space Force succeeding, because it's not just the Air Force that we have to be able to support. We have to support the Army, the Navy, the Marine Corps. It is truly a joint fight, especially when we're up against a peer adversary, that we really have to make sure that the space capabilities that we depend on every day from a warfighting construct, but also from day-to-day activities like GPS and using our phones and being able to get to point A to point B seamlessly, that space is a fundamental fabric of everything that we do in our lives. And so I personally, as the space guy, admitted space guy, for my entire career, say that space is now more important than air. But the other context that AFRL has really worked through that's evolved over the last 20 years that I've been there is space being a benign environment where we were really focused on technology advancement, incremental improvements, making sure that the capabilities continued to meet warfighter needs, to transforming from a technology-focused endeavor to a capability-focused endeavor. And it is no kidding, how do we pull together these end-to-end capabilities from a warfighting concept, both terrestrial support and a space warfighting concept, about how do we actually deliver capability that meets the needs of the warfighter, either warfighter of today or the warfighter of the future that may not be born yet. But what is the capability that they are going to need as opposed to an incremental technology improvement to make the size, weight, power, cost of a component better, more efficient as we try to put it on orbit? And so I think that's the fundamental change within AFRL, knowing that we're not the only element. We have to work with commercial and other government agencies, but it's that capability focus as opposed to a technology focus.
Thank you for that, Dr. Williams. I appreciate it. And really, your role has been described as a conductor. And part of that is you're not just running one directorate, you're coordinating all of AFRL to serve the Space Force needs. What does it actually look like day to day, and where does the baton get dropped most often?
So day to day, my focus is really on the seams and the connections between the different directorates within AFRL. Every directorate, and there are 10 directorates within AFRL, that there's a director that is focused on what are the technologies and the capabilities that they need to deliver within their scope of work. Whether it's sensors technology, materials technology, information, space, they are really focused on those key pieces that fit within their general directorate focus and purview. That's aligned to the program element structure and the funding that we get from Congress. The role that I have is within any organization, especially of the size and complexity of AFRL, there are seams across all of those different organizations. And so my role is to really advocate and enforce the integration across those pieces. How do I make sure that the sensor capability that's being developed for an air platform that can also work on a space platform gets developed for space? And we bring in the information technology piece, the algorithms piece that's needed to make that sensor even more useful, gets integrated into it overall. And so it's really the interaction across the different elements that is the focus of my day-to-day work, because we know that the true capability and breakthroughs come at the seams of technology and organizations. And so we don't want to drop the baton there. And so my role is to make sure that that is effective and efficient. Where we do tend to drop the baton is created by two primary elements. One is when we look to transition technology from the research lab into the acquisition community. There's the traditional valley of death that we could talk about for lots of different reasons. But it's really the challenge to some extent of how the government is funded, how the research lab is funded, and how acquisition organizations are funded. AFRL gets our budget directly from Congress, but we can pivot year over year because of the flexibility that we have as a science and technology lab to go after technology as it emerges instantaneously. When you try to transition to a program of record, they're on a 2-year POM cycle. So our technology is literally ready to go because we had a breakthrough, and now we have to wait 2 years for the POM cycle to catch up. And so we dropped the baton there for a lot of reasons where it's like this technology was cool, or the PEO PAE didn't want to pick it up because it wasn't demonstrated on orbit yet. So we prove it on orbit, but now we have to wait 2 years for that transition. And so that funding structure and the different program elements that we have, with every directorate having a different program element, creates artificial boundaries that forces stovepiping, that creates another baton drop within the enterprise, within AFRL, and then across the different organizations, because we really have to work in a Scrum mentality to go from science and technology to acquisition to operations.
Wow. Just admitting that batons are getting dropped is step one.
Right.
So now that we've admitted that there's a problem, let's talk about some of the potential solutions to that. I mean, how do we prevent that from happening? If you're able to get technology on orbit, and then we got to wait for the POM cycle to catch up, what's a potential fix to that, or a recommendation, or something that we can talk about?
Right. So the first thing that we really have to address is the end-to-end capability. I will admit, when I first started at AFRL, we were focused on incremental technology improvements. We had some breakthrough technologies, but we really didn't look at it as a true warfighting construct of we need a capability delivery from end to end. How do you do the find, fix, track? How do you do the battle management, command and control? How do you provide the effect? How do you do the battle damage assessment of the effect, right? A lot of that we now leverage from a space capability with overhead sensing of the terrestrial battlefield and all sorts of different elements. And so we created technologies and widgets and ornaments, but we didn't look at the entire system, the full tree that we needed to populate. So what AFRL has really been doing under the last 2 to 3 years is we created integrated planning teams that are looking specifically at that integrated challenge. So there are 4 that we're currently doing. One is related to long-range kill web, which is how do you support the blue terrestrial warfighter? We're looking at counter-targeting, which is essentially how do you break red? We are looking at protect and defend space, and we're looking at the nuclear enterprise. But we are looking at it through the lens of not just an independent widget that is going after a singular problem, but how do we integrate the end-to-end capability across the entire enterprise, looking at both air and space capabilities to deliver what the warfighter needs. And we are leveraging the One Lab, Two Services approach within AFRL, where we are really, other than at the secretariat level, we're the only place in the Department of the Air Force where the Air Force and Space Force are still combined. And you mentioned that there's a lot of questions about, is Space Force a real thing? We also get questions of why isn't there a space lab? There's an Air Force Research Lab. Why isn't there a Space Force Research Lab? And it's because of that integrated multi-domain capability that we have to deliver. There are absolutely cases where the only way to solve an air problem is with a space solution. The only way to solve a space problem is with an air solution. And if we really want to create sufficient complexity to deter a peer competitor, we need to do a multifaceted, multi-domain approach in order to achieve that. And that's a large reason why AFRL is still intact and why we are looking at how we do this from an integrated capability perspective.
All I heard was, we definitely need to grow your directorate. That's
absolutely.
I kind of heard that. I don't know if you all heard that as well. But I grew up in Air Force Space Command as a space warfighter. And the Space Force is still young. And in other words, we took Air Force Space Command when the Space Force stood up and we said, okay, you're now all Space Force. We're going to take the Air Force Space Command patch off. And we're going to give you a Space Force patch. Now it's time to start talking about what that actually means, how the Space Force defines what it needs, and how you help describe what those needs are from a system perspective,
right?
A full end-to-end perspective. So let's talk about what that means and what you're working out there at AFRL. And because that lab is so large and so complex, how do you get after that problem set?
It really comes down to communication. That's the kind of the fundamental breakdown of almost all organization is communication, especially in a complex environment. And the Space Force is a good example of that. And what it ultimately comes down to is that the entire process has to be a full contact sport. We have to treat it like a scrum. We have to have the science and the technologists working with the acquirers, working with the operators as an integrated team on a day-to-day, week-to-week, month-to-month, continual battlefield. We have tried it in the past where we do periodic, episodic engagements, and we define what the needs are from the Space Force and what the science and technology work that that AFRL is doing. But what we have learned over the last few years is that we really have to treat this as one team in a scrum together, because we are all critically dependent on each other in order to deliver the capability. And to provide a little bit of an example of that, I don't know what they're called today, but the artist formerly known as SWAC does force design work. And they really are focused on what does the future force look like in the next 5, 10, 15 years. But they don't necessarily know what is in the pipeline from a science and technology perspective. They don't know what is real from the commercial vendors they meet with. What is real? What is vaporware? Because not that commercial oversells, but commercial oversells. That's part of what they do. Because they need to make sure that they meet their next dollar, and we understand that. But there's a role of the lab to help inform the force design. What is the art of the possible? Where does the force design fall apart because we don't have the technology we need as a feedback into the technology and to AFRL? But to really understand what is the art of the possible and what can we be in that future force design. But then we need the acquirers to be involved in that to say, like, it's really cool that you want to go build 160 satellites. We have the industrial capability to build 40. Or we can only afford to build 40. So how does the force design change when we're in a budget constrained environment and we can't actually achieve what you need to? And then you got to bring in the operators that are like, that's a really cool technology. That's a really cool approach, but we are never going to use that because that's not how we fight wars. And I've learned that in my experience. There is, on the Air Force side that we're now evolving on the Space Force side, there's a weapons and tactics conference that occurs every year. It's called WebTac. We meet, we've evolved into a concept with WebTac that AFRL calls Savage Future. And it's how do we get our alpha nerds working directly with our alpha operators? And the reason for that is because the first time I went to an engagement, first of all, I thought they were speaking a different language because fighter pilots have their own language, and I had no idea what they were saying. I understood every other word, so I had no idea what the context was. But I also learned how the Space Force, how the Air Force actually fight wars. And there were a couple technologies that I had in my career where I was like, these are really cool technologies. Why is it that the operator is not using them? Do they not really understand the technology, what the impact was? And it was, no, I didn't understand. That's not how that the US fights wars, and it was never going to transition as a technology. So we really need to treat this as a scrum where it's the S&T folks with the art of the possible, the acquirers understanding what we can realistically procure, the force design folks looking at what are the different parameters and understanding what can we realistically achieve and the impact that they make. And then the operator saying, this is how we would actually employ that. And this is what we need you to do to deliver on capability.
Phenomenal. I tell you, yeah, I grew up as a weapons officer, and we'd have those weapons and tactics conferences on an annual basis. And the expectation was, yeah, you'd have an output that would help drive acquisition to support the emerging threats that we were facing. And so you acknowledging that there is a process that the service has stood up and is really trying to formulate such that we've got a training, testing, tactics development process that you are fully baked and embedded in to support the operational needs and overcome those operational gaps.
Right.
Now, you said a couple of things in terms of emerging tech. Mm-hmm. And I talked to you before coming up here on stage about quantum and photonics and how quantum and AI is going to completely change the game, and how AFRL is kind of attacking that problem set.
Right. We're absolutely funding quantum work. We're absolutely funding AI work. But we're not new to this game, right? We've been funding quantum and AI for decades. Now, a lot of the reason why we've had breakthroughs in AI capability and quantum capability is because of AFRL investments going back into the 90s and 2000s and into the 2010s. And so that technology and that investment has been at the basic research level. That there's a saying that really applies to kind of entertainers, that it takes 20 years to become an overnight success. That is absolutely true from a science and technology perspective. People talk about the revolutionary innovation that went into the iPhone. While it was absolutely an innovative product, it was built on 20 to 30 years of basic science research in microelectronics, capacitive touchscreens, all of these things that came together to enable Apple to deliver on an innovative product. And quantum and AI are very similar. My deputy came from the quantum background, and if you ask him, he'll say that quantum is 10 years out. And he'll say that if you asked him 10 years ago when quantum was going to be, he would have said it was 10 years out. And some of that is true. There are parts of quantum that are still 10 years out, and will probably be 10 years out 10 years from now. But we're starting to understand what are the challenges. But what I think a lot of people don't realize is that we are already leveraging quantum technologies today. The atomic clocks that we fly on GPS satellites that enabled the GPS capability are all built on quantum technology. And so we are leveraging quantum. There is future capability for using quantum for really precise navigation technologies, for like inertial measurement units, for quantum compute and understanding how we can have breakthroughs in computer technology. It's not just how you actually achieve the quantum state within the computer, but how do you develop and write an algorithm that can take advantage of that, because they don't work like classical computers. And so AFRL has been leading a lot of that work, leveraging some of the commercial work that is going on, focusing on what are the military focused things that we really need to leverage our limited resources to go after, while also leveraging and acknowledging that there's a lot of work in the commercial environment.
Thank you for that. You've talked about the importance of maintaining the science and tech pipeline, all the way from basic research to capability delivery. In a resource-constrained environment, what gets cut first, and should it?
100% every single time, it's science and technology, because we are solving the problem of tomorrow, and we are not addressing necessarily the challenge of today. And I think that's a huge problem where we've seen the continual cut year over year of the science and technology budget, even going back as far as sequester back in 2013, that we've never really recovered from. And from a Space Force perspective, I do somewhat understand, right? There's a lot of challenges, there's a lot of priorities in making sure that we have a service that can deliver what it needs to from a warfighting perspective. But the challenge that we have is that the science and technology is very much like your retirement account. And so, yes, I understand that you got to pay rent, you got to pay your bills, you got to deal with, your kid wants to go to summer camp, whatever those things are. But at some point, when you make those transitions to taking out of your retirement plan, you're going to pay for that at some point. And you're actually going to pay a bigger bill later than you are now, because science and technology is exactly like your retirement plan. There is a compound interest rate that you are dealing with, and you are creating tech debt. And if that tech debt compounds year over year for decades, you get to the point where now you have to spend billions of dollars to catch up instead of spending tens of million dollars to pay down that debt to compound over time in order to really leverage the capability that you need. And so I don't know how we message it to senior leaders, to other folks. We've tried lots of different capability ways, but I think the simplest way to understand that is that science technology is your retirement plan. And when we cut that, we are mortgaging the future to pay for today. And I think that is a real conversation that we need to have within the Space Force that is supposed to be the most technologically advanced service that we have.
Yep, spot on. Give us a concrete example. A technology that started as basic research at AFRL and ended up in the hands of a guardian. What did that journey look like, and what nearly killed it along the way?
So I think there's a lot of examples that come to my head that are technology that started at the 6.2 that went with applied research that went into operations. And a lot of the Space Force capability today is built on AFRL technology in the past, like the ESPA ring, the Unified Data Library, a lot of the integrated powerhead demo work that we did out at the Rocket Lab that formed the foundation of the Merlin and the Raptor engines with SpaceX. You can really trace a lot of the capability that Space Force has today to the technologies that AFRL developed 10, 15, 20 years ago. But a lot of those technologies really started at the applied research level. S was when we did that, is an aluminum ring. There was no basic research in how do you design an aluminum ring, but it's been pivotal in addition to all the other things that we funded for small sats to make new space and kind of the rapid expansion of space that we see today possible. But the one example that I do want to give, and I think it's fitting being in the Redwire booth, is the ROSA solar array. So there's for those of you that are of a certain age, there was a Paul Harvey rest of the story kind of segment back in the day. So I want to talk about ROSA because there is more to the story that I don't think people are aware of. The technology that went into ROSA was our third attempt at that technology. In the early 2000s, we had a concept that we were working on called power sail. And it was basically, how do we deploy a large solar array from a small platform? And we were using complex mechanisms to do deployment. They were aluminum mechanisms that had to deploy synchronously in two directions. And it just failed. It was a complete failure. But we learned from that why it failed. We knew that it couldn't be a complex mechanism. The aluminum was too heavy. We had to go to a different approach. So we developed a concept called concentrated strain deployment. And so we would take a composite member and we would put shape memory alloy hinges at specific parts that we needed to fold. And we weren't using the shape memory alloy in the shape memory. It was because they were high strain. So we would use high strain in concentrated places and then use that to deploy on orbit. And it solved a lot of the problems that we saw with power sail. It got rid of the complex mechanisms, but it created other challenges that we ran into. And so eventually we started working on high strain composites, and high strain composites really form the root of the rollout solar array. But we had to develop new materials. We had to develop we had to develop new modeling processes. We had to develop new fabrication approaches. We had to develop new testing methodologies. It was all basic research that ultimately, after a maybe 5 years to a decade of development resulted in high-strength composites that formed the backbone, the structure of the rollout solar array. So it was interesting as a story because we failed multiple times, we learned multiple times, and we ultimately got to the solution that worked. But the other key piece of that, from a basic science to an applied research technology and beyond, is that we don't always know the application of the technology when we first start down that path. We were doing it for solar arrays, but we developed the technology to apply to almost any deployed concept. So antennas, anything that you want to deploy on, and not just on orbit, but also on the ground, anything that you want to deploy can leverage high-strength composites, and we have other applications as well. And a lot of the companies that ultimately formed Redwire, Rocore, Deployable Space Systems, LoadPath, many others, they leverage that high-strength composite technology to multiple products that we didn't even think of when we developed the technology, and it transitioned. But we had to learn, we had to evolve. If we had treated that failure as the end of the program, we never would have gotten to the point where we needed to. And so it comes down to continuous funding. It comes down to the lab being able to fail and learn and adapt, and then ultimately succeed in technology development.
Yeah, and that gets after General Saltzman's vision of creating a min viable product.
Right.
Do not try to create perfection. We know we're not going to get there. So give us a min viable product so that we can actually employ it.
Right.
Appreciate that. If you could get one technology from the lab to operational use faster than the current system allows, what would it be, and what's standing in the way?
The easy, obvious answer for me, because we've been talking about it with Space Command over the last few years, is dynamic space operations. I agree with General Whiting, although it's easy to say that I agree with the 4-star general. But I do, absolutely, from a technology perspective, that maneuver warfare has been important in every other warfighting domain. Logistics has been important in every other warfighting domain, right? There's the old Napoleon quote about amateurs talk tactics and professionals talk logistics. And so from an AFRL perspective, we believe that that dynamic space operations, that space logistics are going to be critical in future warfighting engagements and could be the determining factor of who ultimately is successful. And I know that there's a lot of questions within the service about what are the applications of dynamic space operations, about servicing space logistics, to me, that means it's incumbent on the lab to determine what is real, what can we demonstrate, and what do we need to actually make that successful. And so there's a lot of reasons why we haven't made that leap yet. One is that it's always hard for a new disruptive technology to break through. That's always a challenge. And I do believe that this is a new disruptive technology. It requires some amount of standards. We can't go this alone, right? We need commercial to buy into things like refueling interfaces, how we do a rendezvous and proximity operations. What is the design trade? And then the last piece really comes down to funding. We really need the funding and the funding flexibility to go after these new emerging concepts that we really don't have within the S&T architecture anymore because of the continual cuts year after year. And so while we see it as a real potential game changer, because we don't have that discretionary capability to go fund it, we now have to go sell it to people, and we have to convince people. And then we're in the POM process, and then we have to wait 2 years. And so I think it is a lot of challenges that all combine to, we could have been the world leader in this area. We are not the world leader in this area. And it is an artifact of us not moving at the velocity that we need to move as an enterprise. And I say velocity very specifically for the engineer nerds and the scientist nerds out there that know that speed is all about magnitude only. Velocity is magnitude with direction. We need both magnitude and direction if we are going to stay ahead of our peer adversaries.
Well said, Dr. Williams. I can't tell you how much I appreciate you spending time on the Space Power Podcast. We are honored at the Space Force Association to be the only nonprofit solely dedicated to the U.S. Space Force Guardians and its families. If you want to learn more about the Space Force Association and all the conversations going on, please visit ussfa.org. Thank you, Dr. Williams, for taking time. Really appreciate it. Talk to you soon.
Thank you.
That was Dr. Andy Williams from the Air Force Research Laboratory. I grew up in the era of Air Force Space Command. I've seen what happens when the science and technology pipelines get squeezed, when we choose to solve the problem of today at the expense of the capability we're going to need tomorrow. Dr. Williams put in terms I think anyone can understand. It's a retirement account. And when we keep making withdrawals without contributing, that debt compounds. That's a conversation this community needs to keep having, loudly. Thank you to Redwire for the stage and their partnership. To learn more about the Space Force Association and support our mission, visit ussfa.org. We hope you're enjoying these episodes. We truly love making and sharing them, and if you like them, please share our show with a friend or colleague. This podcast doesn't exist without your support. We have a lot of great ones coming up, even deeper dives, unique perspectives, and insider content you won't want to miss. So be sure to follow the show and turn on notifications. Have any questions? Want to suggest a guest? Let us know. Leave a comment or reach out to us at podcasts@ussfa.org. Space Power Podcast is produced by Ty Holliday. AV for this episode were provided by Redwire. Production support for this episode by Omar Mahmood and Emily Honhart. I'm Bill Woolf. We'll see you next time.